Hello guys, this is about the day 2 class, okay? Day 2, which means the date is up to 17/3/2005. From the last session, we have seen that the basic of the PCB design, yeah, right? Which means basic is nothing but what are the things we have seen in the last classes, what are the overview of the course objective, next what is mean by PCB, next types of PCB, which is are differentiated by the layers, okay, single, double, multi-layer, okay. Other than that, advantages, how, why we are using PCB and its advantages, yeah. Other than that, applications where we are using the PCB. Yeah, other than that, electronic components, the classification of electronic components in passive, active, electromechanical, and types of mounting. Yeah, yesterday thought that what is meant by types of mounting, which is classified into through hole and SMT. Okay. Other than that, PCB design guidelines. Which means PCB design guidelines has a two different. The two types are classified into the SMD and the THD. In guidelines, you know that what a guidelines is nothing but a set of rules, okay, predefined rules, which have to be altered by our manually in the settings of the design, okay. The proper component placement and all I will let us seen in the last class, okay. Further, in today's session, we will discuss about the track with concept. Okay, track with means nothing but a trace. I also mentioned that what is mean by track or a trace. In trace, it only a copper. Okay, nothing but it is a copper which carries the current or signal from the one component to another component throughout the board. Okay, which means the trace consists of copper. Here, when we can see that without the copper trace on the PCB carries the electrical current between components. One component to another component can transfer the currents. Okay, in PCB design using tool like Altium Designer, selecting the correct track with this important to ensure the safe current flow and prevent overheating. Okay, this is the main reason for why you're using the trace with concept is more essential. Okay, other than that, the key points of trace width, okay, wider trace width carries a more current safely. Yeah, I already mentioned that in during the class. The wider trace can for a voltage or a current we need a more wider trace because voltage cannot able to carry a signal in a small width. Okay, for example, the width is so minimum means the current voltage supply cannot be able to properly distributed for the all components. For that purpose, we are providing a proper trace width, which means wider for a current. Okay, voltage. Yeah, in a narrow trace width used for low current signal lines. Yeah, the for example, compared to current voltage traces, normal signal traces are comparatively it is small because the signal traces cannot does not need more trace width. Okay, for example, it carry a small amount of signal means there is a no need of wider trace. It should we provide wider trace means there is a lag in impedance. So in order to avoid that, we want to provide a proper trace width. Okay. Now for third point is a proper track width helps to avoid voltage drop and overheating. Yeah. In this for this area, the third point, it's another example. For example, you are providing a voltage trace, okay, which means current trace which up to the millimeter is above no millimeter, it is 40 mils, yeah, 40, which means mils is another measuremental term in PCB. Okay, there we are using PCB. At the same time we are providing a at the same time we are providing what are the things which you want to implemented in it. Okay, if you have provide a smaller trace width, there is a congestion during the signal transmission. Okay, there is a not able can't able to provide that much of voltage in a small trace. There should be we have facing a voltage drop, so only we are want to provide a proper trace width. Okay, the fourth point is it is defined as It is defined using design rule during the PCB layout. Yeah, it is the main concept because the traces are mostly uh, identified or should be changed during the design rule check. For example, in design rule check, we can able to set the a trace width, okay, for a particular trace. For example, for example, on TDX means nothing but a trace uh, transition end, okay. For a transmission end, we want to provide a proper signal trace, okay. In order to throughout the trace TDX, we want to provide a same trace width. So okay, these condition and all we want to be checked in the design rule check. Design rule check is used, it is a predefined rule which ensure the proper trace along the throughout area, okay. This is this main concept of here. Other than that, via, I also mentioned that via is a vertical interface access. uh, Via is a small plated hole in the PCB that connects the copper traces between a different layer of the board. Yeah, I mean, it is the name via is a reference for the vertical interface access. Okay, now in this via, which means nothing but it's also support for the mechanical strength of the board. Okay, it is nothing but it connects the uh, different layer, which means top, middle, and bottom. There is a more types of via, okay. Let us see in the next. And also it is not only a hole, okay. It is also a plated hole means nothing but it is electroplated or any uh, metal which is the copper plate inside the hole, which means the hole can be act as a conductor, okay, for a top layer and bottom layer. So only we can easy to easily able to transfer the signal from the two different layer or in a multi layer, okay. Now it allows a electrical signal to pass from one layer to another. Yeah, I also mentioned that this is the main role of the via, okay. Let us see in further class how to handle the via, okay. The fourth the other key points of vias, okay. Let us discuss what are the other key points of vias used to connect tracks between layers. Yeah, connect tracks means it is for example, if you have drawing a layer, okay, you want to draw a circuit, which means one few components placed in the top and few components placed in the bottom, okay. The components are not directly connected to the via, okay. The traces are only the connectable thing in the via, okay. One via, the top layer via traces is directly connected to the one via, and the bottom layer traces to the bottom components also connected to the same via, okay. It means nothing but a one components from the top and components the bottom are easily connectable by the via, okay. This is the concept of via. Helps in high multi-layer PCB routing, which means a multi-layer PCB routing means multi-layer consists of more number of layers, which means 12, 16, maximum 10 layers, okay, PCB. And all the wires can be plays a major role, okay. Improves the signal connectivity and layout flexibility. Also here also that the signal connectivity means which means wires are can able to connect from the different layers, so the signal connectivity does not disturbed in any way, okay. This is the main point. Other than that there are different types of wires, okay. Through hole wire, blind wire, and buried wire. Let us show you what are the things, how the wires can be differentiated from one another. Let us wait, I will explain you by showing you a picture. uh, Guys, this is the view of the wires, okay. Wires means nothing but how the wires can be connect the different layers, okay. The first one is here is a through hole wire, which means the wire connected from the top layer to the bottom layer directly. You can see that hole from your naked eyes from here one end to another end, okay. It is a through hole wire. And other than that, here it also mentioned that top to bottom, okay. Another one is a blind wire. Blind wire is nothing but which connects the outer layer to the inner layer, okay, not directly through, okay. It can visible in the one side but does not visible in the other side. Okay, blind via means outer layer to inner layer, outer layer to inner layer, which means not only in a top, it also located in a bottom. If it is bottom means only it can allow to connect due from this layer only. Okay, this is the golden color. It is nothing but a layer. Okay, which means a copper conductivity. Okay, this also the wire. I also mentioned that wires as a electrically copper plated. Copper plated means the wires can be fully surrounded by a copper. Okay, so it can able to transfer the current from the one layer to another layer. Okay, now other than that, you can able to provide a connection between two different layers. Okay, the another one is a buried wire. Buried wire means nothing but these wires can't able to see in our naked eyes during the after the manufacturing also, because these layer are only used in the multi-layer boards. Okay, in multi-layer boards there is a no need of connecting through hole. If we providing all through holes means it's the circuit should be complex more. Okay, in order to avoid the complex, we are using the buried wire. It only connects the inner layer only. Okay, these wires are mainly plays major role in a multi-layer. Okay, no issues for the basic or easy small layers. Okay, let us see other topics. Wait, okay, let us see the next slide. Types of wire. Okay, I also mentioned that types of wire in picture. Let us the same thing also expand here also. Through hole wire. Okay, passes from the top layer of the top layer to the bottom layer of the PCB. Next one is the most commonly used and easiest to manufacture. Yeah, it is also one of the easiest way of wire preparation, because it is no need of any stop in between layer. Okay, it is a hole which is drilled directly one end to the another one. So there is no complexity of creating the through hole wire. Okay, blind wire, it is a concept of I also tell that we can remember. Okay, blind wire means nothing but you can uh, connect the connect layers from outer layer to inner layer. Okay, it do not through hole entire the PCB. Through hole means does not need any direct hole from one end to another. Okay, in buried wire, I also mentioned that buried wires can able to plays major role in multi-layer. Okay, also in four layers and all, the buried wire can't able to use. Okay, in order to use buried wire means it is suitable for multi-layer, which means to connect the inner layer of the PCB boards. Okay, yeah. Next, you want to see about bill of material. Yeah, I also explained that what is mean by bill of material. Yeah, guys, while it is the key card, also you can see that what is bill of material. Bill of material is nothing but a file during the export, which means it is a import file to the manufacturing unit. Okay, it is nothing but it is a set of Excel or a CSV which contains the components part number, components name, part number. Part number is nothing but a specialized number for each component. Okay, each microcontroller or any ICs, there is a exact part number for the each components. Okay, that number, quantity of the component, and what are the specification of the component. Specification of the component means nothing but a for example, it is a resistor means 10 ohm resistor, or a farad capacitor means 10 farad, that and like and all. The specification should be differ. Okay, microfarad, that and all should be differ. Okay, in for example, it is should be a inductor also, it should be differ for the specification. Okay, I tell you that what are this means, component name, part number, quantity, and the specification of that component, and how much component should be used in this. Okay, these are the main things which are placed under the bill of material. And another one is what is meant by package type. Package type is nothing but it should be a resistor. There is a same resistor which has a through hole and SMD. For example, 0806 0805 is one of the part number which has a resistors in through hole and also SMD. For the a requirement of the client, we can set as a through hole or SMD. Okay, these also included in the bill of material. Okay, the second one is concept component list, quantity details, how much quantities of resistors should be used, and component specification. Specification is nothing but a index value, part, package type, then and all. Manufacturing support. Okay, the bill of material is majorly used for a assembly process. For example, it should be like a list of market. Once you get into a market, supermarket, and you get some of the product, and you get a slip, yeah, which means a bill. Okay, you can ensure that what are the components you are purchased, and how much quantity we have purchased, and what are the price. Okay, this is the same for the PCB. For in there you use a bill, which means a bill for our product. Here we using a bill of materials. It is the same. Okay, let us see another one. Mm, real PCB example. Okay, real PCB example means nothing but where our PCBs are mostly used. Mobile phones PCB used in a smartphone to connect processor, memory, and communication modules. Okay, for this area we are using a PCB, and at the same time, computer motherboards. Motherboards is nothing but a board which connects up a lot of components like a capacitor and other chips, etc., etc. Okay, for these integration also we are using PCB and LED driver PCB. Okay, LED driver means also I also shown that LED driver is nothing but a yesterday last class I will show you what are the working principle of Crompton and the basic LED light. Okay, that and all also included here. Next is power supply PCB. Power supply PCB is nothing but a mostly it is used for a power supply. Okay, power boards. Okay, the in technical term is known as power boards. Power boards are most complex to design basically because it carry a full of voltage. Okay, so only we want to care a special pay a special attention to design power boards. Okay, and other than that, Arduino development board. Arduino development board is nothing but a basic controller and components which are used for our projects and all. We are using the PCB. Okay, other than that, what are the workflow of the uh, PCB design? Okay, first of all, it is a main workflow. I on that day I will said that you want to understand this workflow, then only you can carry uh, figure out a complete PCB design cycle. Okay, first of all, you want to create a symbol separately, and you want to create a footprint separately. Okay, once you complete the footprint and the symbol, you want to once you complete the footprint and design completely, you want to uh, combine those both into a single. Once you complete the symbol and footprint, you want to combine the footprint into that symbol. Okay, once you get completed, then you can do the same for the rest of component. Okay, after completing the same process for the rest of component, you can to open the schematic sheet. Schematic is nothing but a sheet where we want to going to draw the schematic design. Okay, in that sheet you want to go pick and place the component what you are already created for the particular project. Okay, you want to pick the component and place in the sheet, and you want to change the name of the component, which means R1, R2, R3. I also mentioned that why we does not want to keep a same name, because it should be a error in a technical error rule check. Okay, then you want to place the all component and complete the connection by watching the reference schematic design or any connection diagram. Once you get complete the connection, you want to ensure that all components get properly connected. Okay, then you want to import the schematic into a PCB. Okay, imported the PCB means then you can able to uh, see the schematic designs, diagrammatical designs into a footprint. Okay, then you can connect. There is a reference line in the component. Okay, one part number one footprint to another footprint, there is a mild line. Okay, mild line, which means a reference line. In during the by seeing the reference line, you can draw the trace from one pad to another pad. Okay, once the cycle is get completed, you want to do the PCB routing. Okay, now PCB routing means nothing but creating a copper trace for the reference line where the component should be connected in the schematic design. Okay, once you get connected the all copper tracks by using vias or from top layer to bottom layer, then there is a connection gets over. Then connection gets over, you want to check the design rule check. Design rule check is nothing but you want to ensure your design as a proper or not. Okay, if you have any error means, then suddenly went go through the error and where is the error causing, which means a spacing or clearance between one component to another component, or spacing between the traces, or any other complexity should be facing means you can be uh, overcome that. Okay, these are the main function of a design tool check. Once you can, the design tool check is comes under zero, then you have a no error in the PCB. Okay, after that you can generate it as a output file, which means a Gerber for a Gerber file, which it is a output for our designers and input to the manufacturing unit, which contains all information about the different layers. Okay, yeah. Okay. So it is a saying that what are the things you want to design. I also mentioned that a circuit design, which means a schematic design. Okay, PCB layout design. Once you completed the schematic design, you can import the design into a PCB layout. The PCB layout get have imported the components are having only the footprint. Footprint means nothing but where the component should be placed. Okay. Okay. Other than that, once you complete the PCB layout routings, you want to check the design verification, nothing but a design rule check for ensure the error-free design for your project. In order to check the designs completely without any error, you want to undergo the design rule check. Fourth one is a manufacturing file. Manufacturing file is for a input for the manufacturer, which contains layer information, Gerber file, and bill of materials, which we have used in our project. Okay. Next one is uh, introduction to Altium Designer. Okay, introduction to Altium Designer as a one of top. It is a tool which has a top three ranking from the all over the world. Okay, so it is a current trend tool. You can able to design the circuit or footprint by using this tool. Okay, for what are the things which are used in the Altium designer is nothing but you can able to design schematic footprint creation, symbol creation separately, as well as you want to add a component libraries and 3D visualization. 3D visualization nothing but how the component is visible to our naked eyes. For example, if you have a guess of the component, it should be seems like that. We can't able to see. Okay, to order in order to see that we can able to see the 3D module, how the components looking like and how it fits in the board, and all we can see in the 3D visualization. Now finally it has a design verification, which means DRC. Okay, in a single platform, it does not, for KiCad it can separately, schematic is separate, tab, and PCB layout is separate tab. Okay, in Altium that it is no need, entire thing is comes under Altium. Okay, application where the Altium is used in means for a basic designs up to basic, it should be involved in a high complex design also, with high complex design, which means multi-layer. It includes 64 layers up to and all can be able to design in Altium. Okay, further you can see how the design is going, how we are providing the designs and all. Next one is features of Altium. I also mentioned that what are the essential features are used in the PCB layout. Okay, advanced routing tools for the high speed design PCB, 3D visualization of PCB boards, integrated component libraries, real-time design, rule check, DRC, support multi-layer. The same thing which I have used to teach in this slide, it is same as here also. Okay, the main advantages of using Altium is it is more effective for the high-speed design PCBs. Okay, high-speed nothing but which want to the board PCB board should be more effective and all. The mainly focused on high-speed design. Okay, 3D visualization is available in Altium. Integrated component libraries also can be accessed when you have a licensed real-time design check. Real-time design is nothing but If you have any design rule mm, clearance also, you can able to rectify in here. Support for multi-layer, yeah, it is mainly used for multi-layer boards. Okay. Yeah, next one is key models in Altium Designer. Key models in Altium Designer also same like that. How we are providing how we are providing the techniques and how we can overcome the design from the step by step. Here, first one is a schematic editor. Is nothing but we want to edit a schematic of like a circuit connection diagram. The circuit connection diagram should be get uh, edited by the schematic editor. Schematic editor, we can place the component and connection should be connected from one component to another component. In case you have to edit some of the connection, means you can able to unclear the previous connection and draw a new connection. Also, you have see some of the components which are placed in the top of the schematic design sheet, where the components should be are mainly focusing for the placing new components like ground, no connection pins, and any other things. Okay. I also mentioned that what is mean by no connection. No connection means NC, where the components which have no connection in the schematic diagram, we want to place the NC, which means cross mark. It indicates that there is a no connection in that pin. So once you place it, there is a no error should be formed in that area. Okay. Next one is a PCB layout editor. In PCB layout editor, you can see that how to place a bias and where should we want to connect and how we want to connect the layers, because you have any issue means there is a design tool check. It will help you to go re- recorrect your error. Okay. Once you go through the DRC, means there is a error should be shown you where the error you are causing and why the error should be causing also. In uh, in Altium, there is a violations should be shown. Violations or clearance are separately shown you. For example, it should be a spacing error, means the spacing error should be categorized in a set of areas. Okay. There is, if there is a 10 spacing error, means 10 spacing error also separately comes under a separate column. And if you have a array placement error, means the placement error also comes under separate column. So you does not bother about where the error should be. Once you click the error, means the Altium PCB layout editor show you where the error is occurred. It zoom in and identify you where the error and how to mitigate that error. Okay. Next, third one is a library editor. In library editor, you can edit the PCB layout symbols. PCB layout symbols or design symbols or layout means something but a footprint. You can able to edit a footprint with by your own. Okay. Let us see how you can able to design a footprint for multi-layer packages. Packages nothing but a ball grid array, FPGA, QFN. QFN is nothing but a quad knowledge package. These packages are nothing but like our mobile phone processor, which means a square shape. The pins are looking under the processor. Okay. These are the main concept of library editor. Third one is a PCB 3D PCB viewer. Okay. 3D PCB viewer. In 3D viewer, you can see that how the board should be visualized after the connection diagram or entered into the PCB layout. Okay. It can be sourced that where the components are you are placing and providing the looks like a real time board. Okay. You can rotate the board from top bottom, flip the board or rotate, and what your which angle you want, means you can able to see that how the board it should be visualized. Okay. These are the things which are available in Altium Designer. In other slide, we are providing what are the how to steps to install Altium Designer. Okay. It should be available in the online platform where you are seeking for the design, which means YouTube, Chrome, how to downloading the Altium Designer. Okay. The basic fundamental process is download installer, run setup, login to account, activate licensed, launch software. Okay, it is a major process for the licensed one. Okay, we want it is only for the licensed way, but we can't provide a license because Altium license should be provided by the company only. Okay, it should be approved by the company. Okay, so it is the only delay for us. So there is a no worries. Okay, you can download the Altium by referring your YouTube. Okay, thank you guys. This is our second day classes. What are the things we are teachers in second day classes? Is content which I delivered now. Okay, thank you. Let us keep in touch for the further updates. Thank you.